Welcome back to the channel for practice problems for actuarial exams. Here I give you some information about resources I provide. The first URL, the first address I give is the address where you can find some information about me, and then resources to study for actuarial exams, PFM, MLC, and MFE. I run online seminars for these 4 exams at Illinois State University, where I'm a professor of mathematics and actuarial program director. You can find information about our actuarial program at smarturl.it/actuary. And if you'd like to make a donation to support our actuarial students, please go to smarturl.it/help-ISU-actuary. So here's a problem for exam MFE for today. Bruce deposits $100 into a bank account. His account is credited interest at a nominal rate of interest I convertible semi-annually. At the same time, Peter deposits $100 into a separate account. Peter's account is credited interest at a force of interest of delta. After 7.25 or 7.25 years, the value of each account is 200. Calculate I minus delta. It's important to note that the expression convertible semi-annually means the same as compounded semi-annually, so that's what you just need to think about. And Bruce's account, after 7.25 years, is worth what? The initial amount that he puts in, which is 100, times 1 plus I over 2. Now, you may not like it that the nominal annual interest rate compounded semi-annually is denoted by I instead of I upper 2, but that's okay. That's the notation in this problem. And you need to understand, if this confuses you, it achieves the purpose. You need to understand what the purpose of actuarial exams is. The purpose of actuarial exams is the same as the purpose of a boot camp in the military. And what is that? Well, it is to get rid of you. What is your purpose? Your purpose is to not give them the satisfaction. So just be calm about it and understand. A strange notation is used here. I is written where you would normally write I upper 2. That's okay. Just think about it as equivalent in this context to I upper 2. So 1 plus I over 2 to the power, and then you would have 2, which is the number of compounding periods in a year, in this case, times the time period measured in years, which is 7.25 years, so 2 times 7.25. Okay, what's 2 times 7.25? It's 14.5. So this is the same as 100 times 1 plus I over 2 to the power 14.5, and we know that this is equal to 200. How do you solve this equation? Because this is an equation in I, and all you need to do is just solve it for I. Divide both sides by 100. That would make the equation 1 plus I over 2 to the power 14.5 equals 2. Okay, then take both sides to the power 1 over 14.5. So the right-hand side would become 2 to the power 1 over 14.5, and the left-hand side would become 1 plus I over 2. So 1 plus I over 2 is equal to 2 to the power 1 over 14.5. So that I over 2 is equal to 2 to the power 1 over 14.5 minus 1. The whole thing multiplied, I over 2 is equal to that thing. And then to get I, you would multiply both sides by 2. So I is equal to 2 times 2 to the power 1 over 14.5 minus 1. And then you use the calculator to calculate that. That turns out to be about 9.7929%. So I want you to note one interesting thing in this equation. All you need to do is just take both sides to the power, which is the reciprocal of the power that you see there. You might be tempted to think that, why don't I just take the natural logarithm of both sides? No, don't do that. You take the natural logarithm of both sides of an equation if the unknown is in the exponent. The unknown is not in the exponent. It's inside there. So just take the power, which is the reciprocal of both sides. On the other hand, do remember that when you're looking in an equation where you're supposed to find something and that something is in the exponent, that's when you will be taking the natural logarithm of both sides. Then, for Peter's account, we have that after 7¼ years, you'll be worth, well, it's deposited 100, its continuously compounded rate of interest, or force of interest of delta. So it'll be 100 times e to the 7.25 delta equals 200. Now look at this. The unknown is in the exponent. So what do you think you're going to do? Eventually you're going to take the natural logarithm. But first divide both sides by 100. That would make it e to the 7.25 delta equals 2. And now take the natural logarithm of both sides. That means that 7.25 delta is equal to natural logarithm of 2. So that delta is equal to natural logarithm of 2 divided by 7.25, and that ends up being 9.5607% approximately. And the difference of the two, we just subtracted two values that we found, is about 0.322%, and that's answer B. Please remember this is copyrighted material, and also problems from past Society of Actuaries and Casualty Actuarial Society examinations are copyright by them, belong to them, are used here with permission, but the solution is mine. Good luck in your studies and good luck on the test.